it's time to start to work with collections of data and learning how we can do that, and introducing collections and something called pandas. And pandas is like the main it's sort of like Excel or spreadsheets that we can programmatically use. But first, a small recap on dictionaries. Say that we have a Python dictionary. We can call it whatever, but we define it by curly brackets, and maybe we have size. Say for example, it's a human, a normal size human. That can be nice, and say it has an age, say 28, and maybe it even has hobbies. This can actually, why not make this a list? Yeah. So maths maybe is a hobby, and computers. Yeah. This makes sense. But inside this dictionary, we can like call for, what is the size? And then we get out normal, or what are the hobbies? And then we say, math and computers. But this is again, it returns a list. So, but we can even like index the list since this returns a list. So index 0 it's math, or index 1 is computers. Or age. And you see that we have used different data types inside there. We have size as a string, we have age as an integer, we have hobbies as a list of strings. So it's like it's just as flexible as these Python lists, but they can even like structure data. But this is just a slight recap on what the dictionary is, but because we'll use it later. What did we learn previously? Import NumPy as NP. We always like NumPy. And what's new now is something called pandas. So import pandas as PD. And this is just something we always do, and since we have NumPy here, and we have pandas here, and we have other references as well. So maybe you can just click on NumPy, since from the last here you see working with the n-dimensional arrays, these ND arrays that we worked with previously, or like now pandas, and going into pandas documents, and here you see like getting started with pandas, and user guides, and pandas in 10 minutes, and we'll start to look into this. But the documentation is really good to have here, close by. Inside NumPy, remember we created like zeros 5 previously. Created like these arrays of zeros or ones. NumPy also has a random number generator that can create the random number of these. It's within NumPy random, and there you have rand n. Rand n. And this is a random number generator, or random number. And this creates these ND arrays. And how many random numbers do we need? Say we need 5 random numbers, and this gives us random numbers. So we can use them to to create the data, create like synthetic data. But pandas main component, or like the fundamental cases, is like, think of it as a spreadsheet where each column is a series, and the entire spreadsheet is something called a data frame. But if we go into pd.series, series, and we can like give in, say, one of these NumPy arrays of 5, and again we get out a series. And this isn't the same as an array, but it's sort of similar. Say we can collect these series in yeah, we can call it series 1, and to just build up, and we can create series 2. Yeah, we can make this a bit longer, but we can collect these two series in a dictionary. Let's just call it yeah, my series, and yeah, like we created this dictionary. That's why I just reminded us how we work with dictionaries. So we can call it A equals, yeah, series 1, and yeah, B that equals series B. And the thing about when you create these dictionaries, you don't use equal signs within, you just use the column series B. And now we have my series, and it contains these two things. But then we can go into Pandas data frame make, and give it in a dictionary of series, and we get out 2 data frames, or 1 data frames consisting of series A and series B. So and this is very spreadsheets alike. So, and that's nice. But yeah, what's the point of this? Usually you package this as something called this is just standard. You can call it whatever you want, but everyone that works with these just call it a DF. And when you look at the documentation, you just call it a DF. So now within DF we have this series, and if we want to just get the we can call it df.head and get the top rows. So now 1 to 4, or if we give it 2, we'll get 0 and 1. And we have a df.tail that gives us the 2 last. So 2 last rows. 1 non stands for not a number. That was sort of created because 1 is just 5 numbers and the other one is 6 numbers. So yeah, it just fitted in here. How do we sort of get out the specific series? So if we have a DF and we just want B, we just call it sort of like how we do it with these dictionaries. And if we just call B, and then we get it out there. Just get myself a few more cells. That's sort of how you get out that. And if you want to get a specific index, say we want index number 3, so this 0.5, you just give it yet another index here, and then we get out this. And you see even what is the data type? It's a float 64. It's a NumPy float 64 actually. We can even, like, if we want to get it back to NumPy, I can try actually. If we dir things, I do like to dir things, because then we get all kinds of insight into what functions we can have on this and all that jazz. You see, there's a lot of functions available to us, but we have here we have a lot of the things: 2 JSON, 2 Excel, 2 NumPy. Yeah, we like NumPy, don't we? So df b dot 2 NumPy. That sort of gives us back the array, back the NumPy array. So type it, then we see it's a NumPy ND array, and back to like the calculation things we just went through. So I like to type things and to dir things. Yeah, I double click D there to remove the cell so it doesn't get in the way. But yeah, this is a sort of a spreadsheet, but we can, if say we want to create a column C, that's some mathematical operator of the rows. So then we just say here, C equals df, say A plus 2 times df. So now B, so now it's 2 times this plus A becomes C. So if we look at the df now we suddenly have another column called C. and now we can sort of start to expand this. Maybe we can even take a take a deeper look in what else we can do. Maybe we can look into if we want to find the difference between each cell. Yeah, probably there's a difference or something. We can dir it again, can't we? I just added a star there. So maybe difference. So shall we search for diff? You have a diff. Maybe let's just check what diff gives us. Yeah, dot diff. Oh, this gives sort of the difference, because yeah, looking at the df here, so we have the first one is a non because it can't take the difference between a number that doesn't exist and the first index, and the diff, yeah, it seems to be that. Maybe we can create that as call it d. So now we have created D, and if we check out, yeah, now we have this. Oh, a lot of nons are collecting up, but we'll see if we can figure them out as well. Sort of, how do we remove nons? Usually we have like something called forward fill, but I used to use like the interpolate function. So yeah, when we dir the df, we can look at all the functions we have available. So interpolate. I went a bit past it. Let's see here. Interpolate. Yeah, I actually like this interpolate function really well. So df.interpolate. What's really interesting now, if we can just run it, and then you see here that it sort of interpolates things, but it doesn't interpolate this. But one thing, when you call functions, you can, if you shift and tab click within the function, you get some helper information here. This is usually called like a doc string, or an overview of. First, it's the overview of the input parameters that you can input into this function, and then you see that there's something called a doc string. So you see here that we can add something limit directions, and the method equals linear, and it is this doc string. This is an interesting thing, and such a helper. You see there's a lot of information here because it goes into the documentation behind it and looks into the code and what people have written. And you even see a lot here. Oh, we even see like interpolate. Oh, tutorial from SciPy. Oh yeah, didn't we see SciPy here? Sort of. I think we saw SciPy here. SciPy, yes, it's SciPy as a reference. But let's look into what that says. Let's see here. Yes, it seems to be a URL. Let's go into that URL. Look here, interpolation by SciPy. Sort of goes into how we interpolate, the different interpolation techniques. This is interesting stuff. And if we want to like use polynomial and linear interpolation, or yeah, so it can be a lot of information just inside this. But yeah, we saw. So here, limit directions. Yes. Let's see here. Do we have like the values we can have in limit direction somewhere here? Here, limit directions, either forward, backwards, or both. Maybe we can, yeah, limit directions both here and see if that works. Limit directions equals both. Now it fixed it. Oh, now we have interpolated it. But yeah, so we call it again. But it doesn't. But it still hasn't like removed these. There's another thing that we need to add on some of the functions we do on dataframes, and that's in place equals true. This is a bit like non-intuitive, but for it to be remembered to the df, we need to add this. So instead of just always just having with these values. So it sort of needs to know that it stores the interpolated results back to the data frame. So in place equals true, and now if we see what's inside the df, now it's here. But back to this docstring thing. We do like to square things, don't we? Square x, yeah. And we can maybe write here takes an input and squares it, yeah. And then we return x times x. So now, if we call the square function and we shift tab, remember that, shift tab, you see here docstring takes an input and squares it. Is it that simple to create a docstring? Actually it is. That's not hard at all. And we can try it. That works. 5. So 5 times 5, I think it's 25. So it sort of works. But maybe if we can we do this? Square. Say we square a equals df square. Can we like input maybe an entire pandas series here? So df a. I went through. That's fun. A. What do you know? Square a. Yeah, we managed to square a. And that sort of makes sense. All the negatives has become positive. Yeah, that's cool. But I don't want it to be named square a. Maybe we can change that. Maybe we have something called rename. Rename. I think we can maybe just shift tab here and try. Yes. What do you know? We do have something called rename. Let's give us a couple of more of these. We can look into this. How do we do this? Maybe there's an example here. Rename and sort of gives in here rename. We give in the columns and again we give in a dictionary. So here things are even called a. So now we take square a here and a, b, c, d, e. So we can call it e, I think. Yeah, maybe I think that works. I need to end the dictionary and end the function. Yes. Oh yeah, now it looks great. Oh yeah. Maybe just add in place equals true again, huh? I think now we have it. Oh, now it's a pretty data frame, isn't it? I think this is sort of starting to become quite useful. But yeah, so that's usually how you can like work with these data frames. Maybe we can sort of create a new one. One thing that I sort of haven't showed you, if we go back to NumPy, we remember this random function that we used previously, but if we add another column here, or add another parameter, what do you know? We sort of created a matrix. So and if you look at like the type here, the type here is what's called ND array. So basically it stands for n-dimensional array, where n is like an arbitrary number. We can have as many dimensions as we want on this on this array type of figure. But we can sort of use this and sort of create the data frame from this as well. df equals, so now it's a new df, so now that will be stored over this. So pd data frame, and we need to give it an mp random.rand and 5 and 3. I think that's, let's go a bit bigger. So yeah, 8 rows deep and 3 columns, and we'll give in columns, and this we give in a list. So let's stick to something that works, something we're familiar with. A, B, and C. Yes. Now look at the df. Oh, now we have more data. Maybe even go wider. 12. Yeah. This actually works. But oftentimes when we sort of want to address or index or look at this, maybe we just want A. Maybe we want to look at A and get that out. So now we only have this series. But what if we want A and B? Then we actually need to give in a nested list here. So we need to nest the list. A and C is probably better. Yeah. And now we out from the df, we want a list of the series that we want to show, and it returns a data frame. So that's sort of how we can sort of look into this. We can also start to something called slicing and slice notation, because if we add another thing here, say that we want from 3 to 6, and now you see here it gives us 3, 4, and 5. So now we have sliced. First we've chosen these, and then we've sliced it again. So now we can get these out, and it returns the data frame. That's called slice, sort of slice notation. We can even do 6, and if we don't have anything at the end, it will just go straight to the end and give us 6 to start, or maybe from the start to 3. Now it will only give us like the 3 first. That's a nice little smiley. But often when we are using these data frames, often we are the index here is not necessarily numeric. Sometimes it's the index is of a date, sort of a timestamp. We sort of looked into the datetime thing, but we can add here, if you see pandas, the date range, the 1st of the 1st of 2022, I think that's, and periods, we can give it 12 periods. Yeah. This is a date time index from pandas, and this thing we can actually give into when we let's sort of create a new one, and we give it index. Yeah, let's just yeah, we can just give in this index equals this. And now if we look at the df, now you see here that the index is suddenly a date time, and it is with increments on the days. But what if we try to want to slice this up? Say previously we sliced it here. We say we want from 3, 4 to 7. Oh, that's nice. It works. It's nice that this works. But sometimes we want to slice by time, and yeah, let's get the datetime library again. Datetime, import a datetime, and now we can create these datetimes. Datetime objects. So first it's the year, and then it's the month. The month, and then it's the day. Say we want from the 3rd. So now we get these at the 0, 0. This is the hour, and this is the second. We can even add like microseconds and even more here. So if we want to specify a specific time and second, so hour, minute, and second, and microsecond, we can do that as well. We saw that in calculations. But can we try to slice this using these date times as well? I think we might be able to do that. Let's try it out. Yeah. So from 3rd, yeah, from this to let's just go to that to maybe the 8th. Can we do this? Oh, look, we can do that as well. So if we have something want to slice by time, we can do that as well and get out these data frames. And if we only want like the B column, we can only get the B column, or if we want B and C column, we need to add this to make this into a nested list and get in the C column. And then what did I do wrong here? Oh yeah, missing this and this. And now we get the B and C column and sliced it with datetime. That's this is quite interesting. But let's one more thing we can, so I can sort of show. Just take this again and let's make a bigger say 25. Yeah, 25. So now we have a new row with 25 rows. Sometimes we want to take this out and just store it as an Excel spreadsheet or as a CSV file or something. That is really simple. We just if we dir the df, I think we saw it previously as well. I think there's something called to Excel to CSV. I can show it to a CSV because that's a simple one to use. df.to just here, and just my CSV file that's CSV, like that. And now if we go back to our directory, we see here my CSV file.csv, and if I click on it, you see here that it contains the data we dumped into it with the index. Now we have a numerical index and not the time-based index. So yeah, if we just now it doesn't have a time-based index. And maybe if we want to read this CSV, then we can that we need to take from the pandas, like the core pandas state library, or that we. So if we dir pd, remember import pandas as pd. It's a sort of like a mantra. There's read CSV. Yeah. So pd.read CSV, and what was it we called the file again? Yeah, we called it my CSV file. See here, and we can read this. And now we read the data back, but it did come with this unnamed 0. Because when it pushed it away, but maybe we can learn and look into if we can remove it. Yes. How do we remove a column? I guess there's maybe we can Google it. Google, how do we remove columns from a data frame? See, I've been here before. Stack Overflow. Stack Overflow is usually a good place to go. Deleting column from pandas data frame. So df.drop. Okay, drop, that's a good. And the column name, and we also need to take in the one. Also drop table. Yeah, here's mentioned in place equals true. Let's try this out. So we can take this again. You see that they use the same notation with the df. So now we have df. Df equals df.drop. Yeah, now it sort of stores it as the new thing, and then we can take this and set it into here. Unnamed 0, 1 df.drop. Didn't it like it's not found as an access? Maybe if I try to Oh, I think read it again. Did I remove it? Drop. Oh yeah, I didn't store this. df equals this. Yeah. So this new df, we need to read it into the data frame. And if we look at the df now, it's this, and now df drop this with access number 1. Yeah, and now we dropped it. And if we search for it now, we can't. Oh yeah, remember, if we get df again now, it's still there because we didn't include. This is where we dropped it, and in place equals true. And now if we search for it, it doesn't exist, because if we df.head, this is that's why sort of it's a lot simpler to just use df.head, because you don't just get all the lines here. So, and now we have removed it, but it also showed another way of removing it. So this sort of said df equals this, and the other one was the df equals the df, and you do the operation on the data frame. But here you create a new data frame from the drop column name. So there are many ways of skinning this cat as well. So it's all well and good. But at least now you have gotten an introduction into Pandas and this extremely powerful data wrangling system. And also, what's also good to know is that these series, they don't have to be like ND arrays. They can even be series of strings. They can be series of Boolean values. They can have different data types. So